Okay, year 10, we're into the final stretch here with the last circle theorem you need to know. This is a tricky one, the alternate segment theorem, and requires clever use of a couple of different rules. Now I'm going to take some time explaining this because it is tricky. The alternate segment theorem, and you know what a segment is because a chord like this creates a segment here and a segment here. Now, the alternate segment theorem says the following. The angle between a tangent and a chord, so that's here, is equal to the angle in the alternate segment. Okay? So, the angle between the tangent and the chord is the same as the angle in the alternate segment. So let me talk this through. Here is a chord. So here is a segment and here is the other segment. The chord and the tangent make the angle here. This angle is on the outside of this segment. This angle is equal to the angle which is in the alternate, so the other segment. So this is one segment. This angle is equal to the angle in the other segment. So in green, just to reiterate that, here is one segment, and in red, here is the other. So the angle between the chord and the tangent here, so you can see this angle is in this segment, is equal to the angle in the alternate segment. So in the green segment, this angle is the same as the other one in the other segment. I hope that's clear. That's just the definition. Okay, now also, this angle here, here's a tangent, here's a chord, so here's the segment. Okay, so here's the other segment. This angle is equal to the angle in the other segment. Hope that's helped a little bit. That's the trickiest one. Now let's look at justifying this. And they have used this a few times on recent GCSE papers. How are we going to prove that this angle here, which I'll colour in blue, is the same as this angle here? Well, first off, I've got to get from here into this triangle somehow. And this angle comes from a chord and a tangent. So what do we know about tangents? Well, we know that they meet the centre point at right angles. That's my clue for those of you who want to try this again. Can you please pause the video now if you want to try it yourself and see if you can justify the rule. Okay, those of you now with me have either just paused and tried yourself or are really not sure and want to see me talk it through with you. And that's fine too. So, what did we learn from this tangent radius that I drew? Well, we know that the tangent and the radius meet at right angles. So we know that this blue angle, add this little slither in here, add up to 90 degrees. So I'm going to call that blue angle X, which means this angle here is the other bit that adds up to make 90. So if that was 70, you'd say this bit was 20. If that was 60, you'd say this bit is 30. You would do 90 degrees, take away this bit. So I'm going to call that 90 minus X. If you want to have a pause now and try it for yourself, you can do. I'll give you a few seconds to think about where we're going next, or just to try it and then watch afterwards to check. Okay, so you've either had a go at this or you're still not sure, and that's fine. This angle here is 90 minus x. It's not the angle in this big triangle, but it is linked to the centre. What do we know about angles at the centre? Well, we know that angles at the centre are twice the angle at the circumference. So let's try and work out the angle here at the centre. What do we need in order to do that? Well, I'm going to draw a line that goes across here. This is a radius, and this is a radius. So what kind of triangle are we dealing with? That's right, it will be isosceles. So this angle and this angle over here will both be the same. Now we can work out what this angle here will be, because we know the three angles add up to 180. So I've got 90 minus x, add 90 minus x, add something, makes 180. Well, 90 add 90 makes 180, so we're already doing really well. Minus x and minus x makes minus 2x. So to get back to the answer bit, which here you can see has no x in it, I'm going to have to add 2x, which means the missing angle here is 2x. Now, if this angle is 2x, what's the angle here? Well, the angle at the centre is twice the angle at the circumference, so this will be x. So now the angle between the tangent and the chord over here is the same as the angle in the alternate segment. This one is tricky, and what you need to do now, year 10, is perhaps not pause the video and draw it down as one diagram, but you may need to make a couple of diagrams of steps along the way, or write the steps down in words underneath to show how you did it. Take your time with this one, watch it again if needs be, make as many notes as you need, and then you'll be in a position shortly to tackle some questions relating to this.